my topic is about cooling for the computing era, the next generation computing. Yeah, I would spend much time on introducing the AI explosion. As you already know, for the past year, the big difference between last year and this year, so the Bitcoin Energy Summit actually is AI. So because mining utilize AI. So the growth of AI obviously is very fast, and actually we are currently facing some new challenges because of the boom of AI. From the thermal side, because the computing density and the heat density rise very much during the past year, because the thermal output of servers goes from about 1 to 2 kilowatts per server to about 5 to 10 kilowatts. So it's 5 times higher than previous IT stuff. So now it's equal to the mining machines for the density, the thermal density. Other than previously, when we started 3 years ago, we just do the cooling for the Bitcoin mining machine because the requirements for the traditional data servers, they don't have such high thermal density. So we just do it for Bitcoin mining. But now, as the thermal density is almost the same, so the latest V100 from NVIDIA comes up to 1 kilowatts per chip. One single chip, 1 kilowatt. So it's ridiculous high. So for the next, the liquid cooling will be the default cooling method other than air cooling. Yeah. So why does computing density matters? Because it's not just for saving spaces, but because my background is computer science, so the density of computing means it can reduce the internal communication distance, so it can increase the computing power greatly. But the problem, the issue is it also increases the thermal density significantly. For AI computing and blockchain computing, to compare both of them. So actually the GPUs for AI computing is just like mining. From the chip side, it's essentially the ASIC. It's general purpose GPU, but essentially it's ASIC because no one uses it to do other things. Use H100 chip to do other things. No, it's so expensive that everyone uses it to do AI computing, right? So it's essentially ASIC. And the users always wanted to have a peak performance all year round, all time, every minute, even overclocked. So it's just like mining. And every user of the AI computing wants it to deploy it rapidly and get up and running very fast. And also it's actually it's tolerant for more downtime, not strictly 100% uptime. So and the ROI calculation, the logic is similar to mining actually. The return cycle, when I talked with NVIDIA guys, they are talking about the return cycle. Not only the computing and technology, but return cycle. The terminology is just like in the mining industry. So it's very interesting. The conclusion is AI computing is more like mining, crypto mining, rather than traditional computing. So it's a new trend for the computing. And so there is some computation now. It just started, the computation between AI computing and proof mining. What we compete? First, they are competing for the most advanced chip processes, the manufacturing capacity. So from the chip supplier, the chip manufacturer, we said that they have to compete with NVIDIA, with Apple for the 3 nanometer, even Intel's 18A, 28 means 2 nanometer. They are competing, and which increases the cost of the chip and the cost of the mining machines. So they are competing. Second, they are competing for energy. Right now, AI computing, the return is higher than mining, but maybe next year, maybe not. I don't know. And they are facing some common challenges like the cooling. As I said, liquid cooling is becoming the default cooling method for either of them, for the next generation computing, either AI computing or mining. And most of them is searching for more efficiency. I mean, the energy usage efficiency, the PUE. I think they will merge finally in the future, someday in the future. But now they share something in common and they are competing. So let's talk about liquid cooling. So there are some different ways of liquid cooling. The first one, is hydro cooling in the mining industry, called hydro cooling. But for the data center area, it's called direct to chip or water plate, cold plate. So it has pros and cons. It's good for the traditional data center to replace the air cooling facilities and to transform to liquid cooling using direct to chip. But the big challenge is that there are multiple sources, heat sources in one server, not only from the chips, but also from other like storage and high-speed links and some other chips other than GPUs. So for the management of multiple heat sources, D2C or hydro cooling seems to be challenging. It narrows the range of application of D2C technology. The second one is single phase immersion cooling. Also, it has pros and cons. There's no silver bullet. So it offers unified cooling for multiple heat sources, and it's capable for rapid deployment in some extreme conditions. Now you don't need to put all the GPU computing power into the traditional data centers to the complicated infrastructure, but you can put it like mining. You put a container into some places that has much energy, much power. That's possible now. So, but it has some disadvantages that the whole industrial chain has not become so mature. The technology is mature, but for the maintenance, we have to prove that there's no issue because the data center area, they are very conservative. The third one is two-phase immersion cooling. Theoretically, it's more advanced, or it's a superior cooling technology and have much more capacity for cooling than any other, because it's two-phase evaporative from the liquid to the air. So, but the big challenge is the overall cost, not only capex but also opex. So maybe the equipment and the liquid, you can reduce the cost by mass production. But for the maintenance, it's not mature. I don't think it's will become mainstream in the years. Yeah, next please. And fourth one is to combine D2C, direct chip or hydro cooling, with immersion cooling, with single phase immersion cooling. Theoretically, it solves problem from both sides, but the new problem is it combines both of the disadvantages from both sides, and it's very complicated because you use direct chip, you use code plate, and also you use immersion, so it increases the cost significantly. But some companies is trying that technology. Generally speaking, the conclusion is liquid cooling offers more advantages, such as it enhances the stability, it improves computing power, and increases the lifespan of the IT equipment, and lower the PUE. So also reduce the building cost of the infrastructure. But there's no silver bullet, so you have to choose what is best for your application, for your specific situation, different scenarios. And liquid cooling, what we have gotten from the mining industry is that because mining industry is more aggressive than the traditional data center industry, so we experience much more than what they do for the traditional servers in the past 3 years, because it's more aggressive for mining. So we can just copy some of the experience to the data center area. Yeah, it's very practical. Next, please. So my point of view is cooling is not just for cooling. The reason is that cooling is the underlying technology, or there's the requirement for more advanced cooling technology. But finally, cooling will change the building logic of the infrastructure for the computing power. It provides a reliable and fast deployable way to extend computing power very rapidly and economically. Because as I said, you can put containerized AI computing power into any environment where there is rich energy, rich power. So that is very important to expand your computing power rapidly. Because they cannot wait, the users of the AI computing power, they cannot wait. They want their computing power to be deployed in 1 or 2 months, not wait for the building of the traditional data center for 1 or 2 years. Elon Musk said in the future, the bottleneck of AI computing might be energy. But with the liquid cooling, especially immersion cooling, as you can find the richest power in the world. So then the energy, in short term, is going to be the bottleneck. And liquid cooling also unlocks the potential of the computing chips, of the AI chips, because it can maintain a peak running status of the chips. I mean, for GPU chips, sometimes it will downgrade when its device is overheated, so it will downgrade. So the average percentage for the computing power is around 50% sometimes. So using liquid cooling, we can increase it to maybe 90%, even lower clock. So that is a huge difference. So the conclusion is that traditional data center will no longer be the first choice. It has higher capex and long building cycle. It won't meet the growing needs of AI computing. So the transformation will come in the next 3 to 5 years, either for AI computing or for crypto mining. With liquid cooling, the transition of the computing infrastructure, building logic is coming. So what's our mission? So we aim to make computing more efficient, more robust, and more economical by our technology, either using liquid cooling or using the software tuning technology combined together to be integrated together to provide the best practices for the computing power. That is our mission. So we have some of our current products, but we also have some more advanced products in the future. What we are doing the early stage R&D right now, and our progress is from last year, the Bitcoin and Summit, to this year. We can offer full stack liquid cooling solutions, technologies, products, services, and we can do customization for different requirements for the computing. And we have all-in-one solution with hardware and software integration. So currently we are delivering the world's first large-scale H100 immersion cooling containerized solution in Asia. That is a large-scale project. After that, we will expand our service capacity to other countries all over the world. I think that's all. Thank you so much.